Dear colleagues, my name is Robert Finger. I'm Professor of Agriculture Economics and Policy at ETH Zurich in Switzerland. Thank you very much for inviting me to present some of our research here at the DigiCrop conference. The main message of my presentation is that digital innovations can contribute to a more sustainable agriculture system. And in the next minutes, I would like to share some perspectives from an agriculture economics and agriculture policy perspective, how we can untap the big potential of digital innovations in achieving that goal. In my presentation, I will start with outlining some ground challenges in the agriculture and food system and also show how digital innovations can actually be used to address these challenges. I will use the example of precision farming in illustrating in more detail where the opportunities but also limitations are and how we can actually untap the big potential of digital innovations. And in the last part of my presentation, I will go beyond the agriculture production side and show how the digitalization of agriculture is also enabling to change and improve our agriculture policy system as it is now. From a global perspective, one of the biggest challenges we face is that many people in the world are still food insecure and face malnutrition. And this problem is not going to disappear. In contrast, we see a rising demand globally for food, whether we express that in calories, proteins, or any other unit. In addition, we see that the demand for many other ecosystem services from the agriculture sector is increasing. So agriculture is more than just producing food. For example, the contribution of the agriculture sector to mitigate climate change is going to be a very important component of increasing relevance in the next years. In the same moment, we see that the agriculture production potential is increasingly under pressure. So it's more and more difficult to produce and deliver the requested ecosystem services. For example, because climate change makes it increasingly difficult to produce the same amount of food. Erosion is a big problem. Also, the competition for many resources that are important in the agricultural sector, whether this is labor, land, or capital. So we see an increasing demand to provide services, but we have a production potential that is strongly under pressure. In addition, we have another problem that the agriculture and food system as it is organized currently has too large footprints on the environment, but also human health and negative social impacts. For example, the agriculture and food system has strong negative contributions to biodiversity decline, to pollution, but also is an important element of climate change. So these problems need to be addressed. In addition, we already see that there's a kind of like negative feedback going back into the agriculture productivity. So agriculture somehow contributes to its own decline in productivity in the future. For example, a study by researchers from Cornell has shown that the agriculture productivity gains in the last decades were to 20% already eaten up by negative effects of climate change, where agriculture and food sector is one of the main contributors. So here we have a triangle of increasing demand and decline in the production potential, and these environmental, human health, and social impacts that urgently need to be addressed. And we believe that digital innovations can play one role in achieving that, of course, being aware that many other solutions are needed and need to be combined with digital innovations to achieve that. A couple of years ago, we published an article under the lead of Professor Achim Walter from ETH Zurich, where we highlighted that digital innovation, smart farming, can contribute to more sustainable agriculture in a way that the environmental footprint is reduced, that animal welfare is increased, that farmers' income can be increased, and that even social sustainability can be improved. We also highlighted in that article that technology alone, a new machine, a new software, a new robot is not sufficient to achieve any of these goals, but that really needs to be carefully combined and embedded in a bigger system where we have also good institutions, good policies. We also have a diversity of solutions ready. So it's not sufficient to focus on a specific type of farms, a specific type of crops, but the diversity of agriculture globally needs to be reflected in the solutions that we provide to farmers. And we highlighted the role of networks. That means interaction between farmers, interaction between farmers, consumers, and other stakeholders can be need to be fostered with digital innovations. So to become more specific, what contributions can digital innovations make to make the agriculture sector more sustainable? We believe there are multiple entry points. Among them, efficiency, substitutions, and redesign. What does it mean? Digital innovations can be used to make the agriculture sector more efficient. So, for example, precision farming is an excellent illustration how the use of specific inputs like fertilizer, pesticides can be tailored much more to the actual needs that we have in the field. And in that way, we increase efficiency. We maintain the same level of production or even increase it and decrease the amount of inputs used. So inputs are only used where they're actually needed, and digital technologies are a key element of facilitating that transition. So we have a loss of waste, and this actually is a very good thing both for the farmers and the environment. But yet that may not be sufficient because we still use critical inputs, for example, like pesticides. So the next step should be to substitute to strategies that are less harmful for the environment, for example, and human health. So a good illustration here is the substitution of herbicides to control weeds by using, for example, a weeding robot that takes over that role without actually relying on chemicals. So this is a substitution towards more environmental friendly practices. So efficiency and substitution go hand in hand in reducing the footprint of the agriculture sector. But both steps are not sufficient because we still fix a broken system. So we still have the problem that we need to address. So for example, a pest that is emerging in our agriculture system that we need to tackle. So the next step is to redesign our agriculture systems in a way that we avoid and reduce the problems actually occurring. So creating diverse agriculture systems that do not face the same pest pressure as in the current agriculture systems. Also here, we believe digital innovations can play a vital role. And along these lines of redesign, aspects of agroecology will feed strongly in the redesign of agriculture and food systems and will allow to actually reduce the need for costly and harmful interventions that we currently make in the agriculture and food sector. Precision farming is a good example for the potential role of digital innovations. I indicated that already. And here I'm relying on a review article that we have written a couple of years ago. But precision farming has a very large potential because precision farming enables agriculture management to be tailored spatially and temporally, both in crop and livestock production. A very good example is the targeted use and substitution even of inputs that I just illustrated in on the last slide. So this identifying where the problem is, addressing the problem exactly where and when it's actually needed is an important leverage to reduce waste. And reducing waste, so not wasting inputs like fertilizer and pesticides, means we cut and reduce the private variable cost. This is good for the farmer, but in the same moment in time, we also reduce the public, so the environmental cost, and this is a good thing for the society at large, because less of these inputs are lost into ecosystems and there are less damages to the environment and human health. So this is a strong component of efficiency gain and substitution, as I outlined it. However, even though the potential of technologies like precision farming are massive, seen from a global perspective, because they can be used in many different applications, we currently see that the use of precision farming technologies is limited to specific type of farms. Often these are rather large farms that are the main adopters. We see also that many agricultural systems, for example, in Europe, have a comparably low uptake of these technologies if compared, for example, to the US. And we also see that more complex precision farming technologies, as the variable rate input use that I just described, are adopted less than the less complex technologies like the guidance system. So here more can be gained. So higher uptake rates of precision farming would allow actually to untap the potential to cut both private and environmental cost. And exactly that big benefit that is potentially there is, in our opinion, justifying a greater public and private intervention. So creation of incentives to encourage the adoption worldwide. How do we do it? So how can we actually trigger the larger adoption and contribute with that to more sustainable agriculture? First of all, we need to combine both public and private support, especially in a system like European agriculture where public intervention is very large. We need both. A key element to achieve that is to provide good infrastructure in terms of technologies, internet, and so on, but also a legal infrastructure is needed, just making the reference to autonomous machineries and how and whether they can be used in the agriculture sector. That needs legal frameworks that are working for farmers and all the other actors involved. But we also need education and information, of course, and we need economic incentives to the farmers that stimulates the use of new technologies. And this is particularly needed because new technologies as precision farming often for many farmers simply do not pay off sufficiently. That means the expected benefits are smaller than the cost of these technologies, and or that the risks that are involved in that are arising from an investment in new technologies is simply too large compared to the benefits that it may provide. And to overcome the lack of economic viability, we can actually use two strategies, push and pull, and we probably shall combine these two strategies. What means a push strategy? And key obstacle in the current system is that the harmful inputs that we want to reduce or substitute, like pesticides, are too cheap. So a weeding robot is not paying off currently because herbicides are simply too cheap. They are also too cheap because the kind of public cost, so the pollution component of herbicides, are not part of the price. So increasing the price of herbicides, making, so to say, the true cost of herbicides being accounted in their price, using, for example, taxes, would make technologies that reduce or even substitute the use of herbicides fully more attractive. On the other hand, a strategy that is also often used is a targeted support or even subsidies for specific technologies. So overall, both strategies, push and pull, can make the investment in digital innovations more attractive. We have also shown in recent publications that another component that is extremely important is to go beyond a single farm. So we often focus on the single farm. The single farm should adopt specific technologies, but it's not going to be a viable strategy. In contrast, we need to focus much more on aspects of cooperation, collaboration between farmers, and enable that technologies are entering the sector via these channels where farms operate jointly with new technologies. And an important element in there are also contractors, service providers that actually bring new technologies and new information to the farms. So here we need to kind of like switch our attention from the single farm to the regional scale and how the technologies can be implemented here. Along these lines, we also need to embed digital innovations in a bigger policy picture. So we clearly need to show how digital technologies can address many different policy goals and how also different policy elements affect the attractiveness of digital technologies. In addition, we need to integrate digital innovations in entire value chains. So of course that involves the input and technology providers, but also actually has to go via the farmers also to the processing and the selling of food, because some technologies may have attributes that are not perfectly suited to the demand of the downstream actors. So here we need to align along the bigger policy picture and the entire value chain. However, whatever we do, we believe that just saving inputs and just producing more outputs using digital innovations in the agriculture sector is never going to be sufficient to exploit the full potential and to realize the big potential in terms of also uptake in the agriculture and food sector. So there is more to be gained from digital innovations than just saving inputs and increasing slightly our production levels. And there is indeed many aspects that can be very useful in addition to that. For example, new technologies like precision farming will allow to create totally new data sources that can be useful to increase the transparency in food production chains, but also can increase the transparency from farmers to policymakers and other stakeholders, but also can reduce the administrative burden to the farmers. In addition, new digital technologies will create interfaces where the kind of like communication between different actors is facilitated or even enabled. So an interaction between farmer to farmer, sharing experiences almost live in the field, an interface between farmers and down and upstream actors that can give valuable information for decision making. So all that is going to be of vital importance to untap the big potential. We also believe that digital technologies shall not just be used for efficiency gains and substitution, but really also can and shall be used to redesign agriculture and food systems. And there are different entry points. I tapped on some of them a couple of minutes ago, but we also believe that digital innovations shall be really tailored to not only improve the production of food and make it more efficient, but should really also be used to contribute to conservation. So precision conservation is an important keyword here that can be of vital importance, obviously from an environmental perspective, but also from an economic perspective. So what does it mean? Digital technologies and innovations can be used to make conservation activities, biodiversity maintenance, or even improvements more efficient, because new technologies can be used to outline where a specific action, like reducing pesticide use, using flower strips, and so on, can be particularly effective in maintaining or increasing biodiversity, and at the same moment in time also indicate where this action is actually realized in the most efficient way. So where the cost for achieving a specific level of biodiversity is lowest. So here are plenty of opportunities to actually realize better outcomes of the agricultural system at large to a better price. And we see that increasingly the income of farmers in terms of subsidies, but also payments from companies, is more and more relying on the actual services that they are also delivering, like biodiversity, like climate change mitigation. And this is going to be an interesting and relevant area also from an economic point of view. And in addition, we believe that digital technologies can and shall be used to also change and improve our agriculture policy framework. And also this is a kind of like redesign of the system where digital technologies can contribute. So what does it mean if we think about digital technologies and agriculture policy? I'm here referring to a paper on agriculture policy in the era of digitalization, with Melf-Hinrich Ehlers being the lead firm. What you see here in the center of the slide is a policy cycle in a very reduced form. So basically the story is that we have a problem, and the problem is framed in agenda setting takes place, and this steers the formation and implementation of a specific policy. So take, for example, we have the problem of pesticide pollution, and then a policy is formed and implemented that, for example, gives subsidies to farmers to use less pesticides. And then the next step is the evaluation of these policies. How effective and how efficient was the implemented policy? And then this result of the evaluation feeds back to the problem framing, agenda setting, and the cycle continues. And we believe that in all of these areas, digitalization of the society at large, but also of the agricultural sector, will change this policy cycle massively. So maybe starting with the evaluation, it becomes clear that increasingly we can use digital technologies to evaluate outcomes of agricultural policies. One low-hanging fruit is the use of remote sensing to identify what farmers actually do and what the outcomes are of what they do. So for example, we can make use of satellites to identify what crops are grown where. We can identify when, for example, specific management action like fertilizer application, tillage, but also mowing or grazing activities take place. And this can be an important element to actually control and kind of like enforce agricultural policies. But also going beyond that, we can envision that the increasing collection of data and connection of data will be an important source to detect inconsistency in the reporting of specific inputs like antibiotics. But even we believe that the implementation and formation of agricultural policies is going to be changed and improved with the use of digital technologies. For example, the policy solutions using digital technologies will become more tailored spatially, tailored temporally. One example we highlighted here is that we can tailor policy measures to a specific point where erosion potential is very high and mitigate erosion using targeted policies. What does it mean? We can use digital technologies, whether this is remote sensing or something different, to highlight where in space the erosion potential is very high and directly make an intervention at these points in space where the erosion potential is high and give farmers an immediate feedback and maybe also an immediate incentive to avoid erosion at exactly that point in space. The same may occur for the pollution of water bodies or other ecosystems, where there can be a live feedback between measuring the outcome and giving back in an immediate and digital framework and feedback to the farmers. So overall, digital technologies and the use of machinery and software that documents more and more what farmers are doing, where, when, and how, can make farmers' actions and the outcomes arising from these actions more transparent and more specific, because we know exactly where in time, space, something is happening. For example, if you have precision farming equipment that documents where, what, how was sprayed, we have a very clear and so far inexistent record of pesticide applications. And we can make connections of that to the outcomes. So we can make connections to biodiversity loss and or other aspects like effects on human health. So this is something that will create new opportunities to create better policies. And this is more than just digitizing the existing instruments that we have. So it's more than just documenting electronically activities like the activities of cows or the application of specific inputs. It can be more. As I illustrated, there's a big potential to really make use of the location specificity, the intertemporal flexibility that is arising from digital technologies, both at the level of the farm, but also beyond, if we take remote sensing as an example. So this is overall really allowing to create new type of instruments, as I tried to illustrate. So making use of the location and the time-specific policies that can be realized. Another element that we believe is important in that policy context is that we can push towards more result-based policies using digital technologies. What does it mean? Currently, farmers are incentivized and giving regulations related to specific inputs. So how much fertilizer can be used where? So there's an intervention at the level of the input, but not necessarily this is connected to the result that we are interested in. Is climate change mitigation potential used? Is biodiversity not declining? Are rivers not polluted? These are the goals that we want to achieve. And more using digital technologies, cheap sensors in the environment will allow to really clearly monitor the outcome of activities. So the state of the water body, the state of other ecosystem services. And this is something that we can make use in policies by giving farmers payments for reaching specific goals. And this can be really facilitated using digital technologies, and this will be an important leverage to make these technologies and the widespread use of technologies more attractive. So overall, creating better and more effective and more efficient policies can contribute to make the agriculture systems more sustainable. But there are many elements for policies to fill specific gaps of the current state of our agriculture and food policies. So in that paper here, also led by Melvin Rich-Ehlers, we developed scenarios for European agriculture policy making in the era of digitalization. So we created some plausible scenarios of digitalization of the agricultural sector, and we didn't judge which is the best for whom or which is the most probable, but all of these scenarios have some kind of like potential to be realized, at least partly. So this ranges from a light digitalization scenario, so the way we operate right now, but also includes scenarios of autonomous technology on the field, but also in the food system, in the food processing is taking more and more over the job, towards a scenario on digital regulation where basically the government is playing the most important role in steering steering the system and managing information. So there are different scenarios that are plausible for the future developments, and we identified where are the agriculture policy gaps and what can we do to fix these gaps. And some things that were emerging across all these scenarios are that a policy strategy to address these gaps in an uncertain world, in an uncertain development of the state of digitalization in the agriculture sector, is that we need to develop digital infrastructure. So this is key, but we also need to develop competencies to actually work with digital solutions. And this is not only referring to competencies at the level of the farms, extension services, and input suppliers, but that really goes along the entire value chain to the policymakers. So the examples I just highlighted on the potential for agriculture policies to be improved also involves that the persons making decisions at that stage really are sufficiently educated to see the potential, but also the limitation of digital technologies at specific applications. But we also need to be ready to address the special cases. So in one of my first slides, I referred to that diversity, and this is the key. We have a diversity of cases, a diversity of farming systems, farmers, and we need to be ready to address this diversity and address special cases. And this entire strategy also needs to contribute to more resilience in the system, so that the system is capable of coping with unforeseen events. But all that need to be addressed in order to be ready for a digital future of the agriculture sector. And currently, the agriculture policy, as we see it, is not ready to cope with that and not ready to untap the full potential of digital innovations. So to conclude, digital innovations can contribute to more sustainable agriculture systems, but more than technology alone is needed. So this really needs to be combined and extended with other dimensions than just developing new technologies. We see that digitalization and new technologies like precision farming have a massive potential that is currently underexploited globally, and especially also in European agriculture. And in order to kind of contribute to filling this gap, we of course need a further advancement of the technologies that are around, that are ready to be used by farmers, but this shall be also combined with an effective implementation and a responsible governance structure. And also, we would like to highlight that promoting digital innovations needs more than just a focus on saving inputs and producing more outputs. Other benefits can and need to be untapped. So I highlighted a couple of them: the aspect of transparency within value chains, the contribution to conservation, to biodiversity improvements using digital technologies, but also the contribution to better agricultural policies are vital here. So there are many areas beyond saving inputs and producing more outputs that need particular attention, and only this is also incorporated, then the big leverage of digital technologies can be actually used. And finally, we need a holistic assessment and embedding of technologies and policies within the bigger agriculture and food system. So going beyond the individual farm is an important element here as well. With that, I would like to thank you very much for your attention and refer to some more sources where to find more details on our research. We have a blog I'm inviting you to follow, and also I would like to refer to the World Food Systems Center at ETH, where a lot of this research is also embedded. Thank you very much for your attention.